Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to mechanics and the chapters of mechanical actions, equilibrium of a body and Archimedes upthrust. This exercise was a previous one in the brevet exams in 2006 first session, third exercise. The title of this exercise is hollow sphere. The aim of this exercise is to determine experimentally the volume of the cavity of an iron sphere S, given that G is equal to 10 newtons per kilogram, which means that we are performing this experiment on the surface of Earth. Now, before we refer to these experiments, let me explain what is meant by cavity. So, the given solid S is a sphere, and by cavity means there is an empty space in the solid. So, in the solid S. Now, suppose that this solid has no cavity, so we expect that it is made up of iron first. So if it has no cavity, so it is supposed that it's completely made up of iron, like this. Now, if it has a cavity, then there is an empty space inside the solid S. So this is the part which is made up of iron, like this. And this part is the cavity, which is an empty space inside the sphere S. So the aim of this exercise is to determine whether the solid S, the given sphere, is made up of cavity or no. For sure, looking at the sphere from outside, one cannot determine if this sphere is made up of cavity or no. So we must proceed using these experiments. Now, part 1, first experiment. We attach S to a dynamometer. So by dynamometer, it's meant a spring balance. The dynamometer indicates 7.80 newtons at equilibrium, so this is important. Now we are in the first experiment, part A. Name the two forces acting on S. So because we suppose that the sphere S has a mass, then it will be directly subjected to the weight. And because we have a spring balance, then the other force is given by the tension T. So recall that whenever we have a spring or a string, then the solid S will be subjected to the force along the spring or the string, which is given by the tension force. Now part B, give the relation between the values of these forces. So the relation between the values here, the values means the magnitudes. And by the relation, it is the equality, knowing that the solid S is at equilibrium. So in other words, they are asking me about the condition of equilibrium. So let's write as a title at equilibrium. Then how do you apply this condition? Always on the left hand side we write the sum of forces acting on the solid S, and they are given by the weight and the tension. So let's write weight vector plus tension vector. And on the other side of this equation we write a zero vector corresponding for the condition of equilibrium. And we don't forget the vectors over all of these three quantities, and especially the zero. Now moving T to the right hand side, we have that W vector is equal to minus T vector. What does the first equation tells us? That the effect of the forces acting on the solid S cancel each other to give us the zero vector, whereas the second equation tells us that both forces have the same line of action, the minus sign for the opposite direction, and same magnitude. Now notice that we didn't answer the question yet. They are asking me about the relation between the values, so we are interested in the magnitudes. Then let's write in magnitude. Now, how do I extract the magnitude relation from the vector relation? Simply we drop down the vectors and remove the minus sign. So the weight is equal to the tension. So this is the relation that we are asked about. Now in the same part, they are telling me to deduce the mass of S. So in order to determine, first of all, what does deduce means? That we need to use the previous part. In the previous part, we have determined the relation between these values, between the values of these forces, and knowing that the dynamometer indicates 7.80 newtons at equilibrium. So here from the indication of the spring balance, we can say that the weight is equal to the tension is equal to 7.80 newtons. So knowing that the value of the weight now is given by 7.80 newtons, we need to deduce the mass of S. We know that the mass and the weight are related via the following formula, that the weight is equal to m multiplied by g. Here let me state that the weight is given by 7.80 newtons. Knowing that we are interested in determining the value of m, so constructing the triangle of this formula, here because we have multiplied and w will be at the top, m and g at the bottom, we are interested in determining the value of m, which is given by the ratio of w and g. Now the value of w is given by 7.8 and the value of g is given by 10 since we are performing this experiment on Earth. Now the value of this fraction is given by 0.78 since everything is expressed in the SI, so the value of m will be expressed in the SI, which is kilograms. Then the mass of this sphere is given by 0.78 kilograms. So let me write here that the value of the given mass of the solid S is given by 0.78 kilograms. Now calculate the volume, part C, calculate the volume V1 of iron given the density of iron is equal to 7,800 kg per meter cube. So knowing the density and we have determined the mass, so the mass and the density correspond for the iron because the sphere S is made up of iron. We know that the density, the mass and the volume are related via the following formula, that the density is equal to mass divided by volume, and we are interested in determining the volume. So constructing the triangle of this formula, here because we have divide, then rho will be at the bottom, m here and v here. So putting our hand over v, then v is given by, which is denoted by v1 is equal to mass divided by density. Now the value of m is given by 0.78. The value of the density is given by 7,800. Now plugging this fraction on the calculator, then the value of v1 is given by 1 times 10 to the power minus 4. Since everything is expressed in the SI, the mass and the density, then the volume v1 will be expressed in the SI, which is meter cube. Now v1 is equal to 1 times 10 to the power minus 4 meter cube. And what does v1 represent? v1 represents the volume of iron. So we have determined v1 using this formula where m represents the mass of iron and rho represents the density of iron. So because v1 is the ratio between m and rho corresponding for that of iron, then v1 represents the real volume of iron. Then let me write here that v1 is equal to 1 times 10 to the power minus 4 meter cube corresponding for the volume of iron in the sphere S. Now number 2, second experiment. The sphere S is still attached to the same dynamometer, is completely immersed in water. So we know that this statement is very important. What does it mean that it is completely immersed in water? That the immersed volume in this case is equal to the total volume of the solid S, or the outer volume. Now in this case the dynamometer indicates 6.3 newtons. And here, because we have a liquid which is water, we must directly think of the apparent weight. So in part A, they are asking me what's the value of the apparent weight of S. So here, because they are asking me about the value of the apparent weight, so we must justify why 6.3 newtons represents the apparent weight. Simply because the sphere S is attached to the dynamometer at equilibrium for sure and immersed in liquid. Then let's say since the sphere S is immersed in a liquid, at equilibrium, then the spring balance, or let's say the dynamometer, indicate its apparent weight. So in this case, the apparent weight is given by W apparent, which is given by 6.3 newtons. So here we have the W apparent, (6.3 newtons). So what does then the previous weight represent? So because in the first experiment we performed this experiment in air at equilibrium, so this weight represents the real weight. Now in the same part they are telling me to deduce the value F of Archimedes upthrust exerted by water on us. So by deduce it means that we need to use the previous part, and by the value it means the magnitude. So because we have the value of the real weight and the value of the apparent weight, so the value of F can be determined from the difference of the indication of the two dynamometers, which is given by the real weight, which is noted by W minus the apparent weight. The value of the real weight is given by 7.8 and the value of, real weight 7.8, apparent weight 6.3. Plugging this on the calculator, then the value of F is given by 1.5. Since both the real weight and the apparent weight are expressed in newtons, so the value of F will be expressed in newtons, which is in the SI. Then the value of F is given by 1.5 in newtons. What does F represent? It is the magnitude of the force exerted by the liquid, which is water, on the sphere S. So here the value of F is given by 1.5 in newtons. Now let me make some space. We are in part B. Determine the volume V2 of the sphere given the density of water is equal to 1000 kg per meter cube. So we know that the volume, the immersed volume, and the value of F are related via the following formula, that F upthrust is equal to the density of the liquid times the volume of the immersed part times G. We are interested in determining the immersed volume, or the volume. So notice that here they are asking me about the volume V2 of the sphere and not the immersed volume. But whenever we are able to calculate the immersed volume, problem solved, because here we have that Vi is equal to V. So first let's determine the immersed volume, then we will justify why V2 is equal to Vi. So constructing the triangle of this formula, here because we have multiplied and F upthrust will be at the top, rho L, Vi and G at the bottom, we are interested in determining the immersed volume, which is given by Vi, which is equal to the magnitude of F upthrust divided by the density of the liquid multiplied by G. Now F upthrust is denoted by F divided by rho L multiplied by G. The value of F upthrust is given by 1.5. The value of rho is given by 1000 from here in the SI, and the value of G is given by 10. Plugging this fraction on the calculator, then the immersed volume is given by 1.5 times 10 to the power minus 4. Since everything is expressed in the SI, so the volume Vi will be expressed in the SI, which is meter cube. Then Vi is equal to 1.5 times 10 to the power minus 4 meter cube. Recall that they are asking me about the volume V2 of the sphere and not the immersed volume. So now let's justify that since S is completely immersed in the liquid, then the volume, which is denoted by V2, is equal to the immersed volume is equal to 1.5 times 10 to the power minus 4 meter cube. Then the volume V2 is given by 1.5 times 10 to the power minus 4 meter cube. And let me write here that V2 is given by 1.5 times 10 to the power minus 4 meter cube. So this is the volume of the sphere. So the outer volume of the sphere, because it's due to water displacement or due to the immersed volume. Now part 3, volume of the cavity, part A. By comparing V1 and V2, so first let's do the comparison between V1 and V2. The value of V1 is given by 1 times 10 to the power minus 4 meter cube. And the value of V2 is given by 1.5 times 10 to the power minus 4 meter cube. And by compare, it means that we need to say whether V1 is greater, smaller, or equal. Since they have the same unit, then in this case the value of V2 is greater than V1, because the value of V2 is given by 1.5 times 10 to the power minus 4, whereas V1 is given by 1 times 10 to the power minus 4. Now they are telling me by comparing V1 and V2, verify that the sphere S is hollow, and the word hollow means that it has a cavity. So notice that here in this case V1 is not equal to V2. Actually V2 is greater than V1. Why? So let's recall, what does V2 represent? It represents the volume of the sphere, whereas V1 represents the volume of iron. So this is the sphere S. So V2 is equal to 1.5 times 10 to the power minus 4. So this is the volume V2, the outer volume. And if we suppose that the solid S is completely made up of iron, so it's completely made up of iron, then we expect that the volume of iron must be equal to the volume of the sphere, which is 1.5 times 10 to the power minus 4 meter cube. And in this case, the volume of iron is less than the volume of the sphere, and this is due to the presence of a cavity which is inside the sphere. So now this is the volume V1 represented here, which is given by V1 is equal to 1 times 10 to the power minus 4 meter cube, which is less than the volume V2, which is given by 1.5 times 10 to the power minus 4 meter cube. And the difference between these two volumes, so V2 is greater than V1, and the difference is due to the presence of a cavity inside the sphere S, which means that the sphere is hollow. Then the justification is given by, or the verification is as follows. So let's say since the volume V2 of the sphere is not equal to the volume of iron, then the sphere S is hollow. And recall that by hollow it means it has a cavity. Now in part B, calculate the volume of the cavity. So as I have stressed earlier, that the volume V of the cavity is due to the difference between these two volumes. So we will subtract, so let's say V2 minus V1. Why V2 minus V1 and not V1 minus V2? Because simply V2 is larger than V1 and the volume of the cavity must be positive. Now the value of V2 is given by 1.5 times 10 to the power minus 4, and the volume V1 is given by 1 times 10 to the power minus 4. Plugging this on the calculator, then the volume V of the cavity is given by 0.5 times 10 to the power minus 4. Since both V2 and V1 are expressed in the SI, which is meter cube, then the volume V will express in the SI, which is meter cube. Now V is equal to 0.5 times 10 to the power minus 4 meter cube. So what does V represent? It's the volume of the cavity inside the sphere S. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.